Our journey begins right here on Earth, a planet teeming with life. Earth is our home, a small blue planet orbiting a yellow star we call the Sun. This is where our cosmic address begins. Earth is the third planet from the Sun in our solar system. We revolve around the Sun, a giant ball of hot gas that provides us with light and warmth. Without the Sun, life on Earth would not be possible. Our planet is just the right distance from the Sun for liquid water to exist. This is essential for all life as we know it. Earth is truly a unique and special place in the vastness of space. From our perspective on Earth, we can see other planets and celestial objects in the night sky. These distant points of light hint at the vastness of the universe beyond our own planet. Our solar system is like a giant family with the Sun at its center. 8 planets, including Earth, orbit the Sun in elliptical paths. Each planet has its own unique characteristics and features. The inner 4 planets, Mercury, Venus, Earth and Mars, are rocky planets. They are relatively small and dense with solid surfaces. The outer 4 planets, Jupiter, Saturn, Uranus and Neptune, are gas giants. They are much larger than the inner planets and are composed mostly of gas and ice. In addition to planets, our solar system is also home to countless asteroids, comets and dwarf planets. Asteroids are rocky remnants from the early solar system. Comets are icy bodies that release gas and dust as they approach the Sun. Dwarf planets are celestial objects that are large enough to be round but have not cleared their orbital paths. The solar system is a dynamic and ever-changing place. The planets and other objects are constantly in motion, orbiting the Sun and interacting with each other through gravity. Our solar system is just a tiny part of a much larger structure called the Milky Way galaxy. A galaxy is a vast collection of stars, gas, dust and dark matter held together by gravity. Our Milky Way is a spiral galaxy, shaped like a giant pinwheel with arms spiraling outwards. Imagine looking up at the night sky and seeing a faint band of light stretching across the heavens. That band of light is the Milky Way galaxy, our home in the universe. If you could see it from above, it would look like a giant whirlpool of stars, gas and dust. The Milky Way is estimated to contain hundreds of billions of stars, each one a sun like our own. It's a truly enormous structure, spanning over 100,000 light-years in diameter. To put that into perspective, 1 light-year is the distance that light travels in 1 year, which is about 5.88 trillion miles. Our solar system resides within one of the spiral arms of the Milky Way, located about 26,000 light-years from the galactic center. We are but one small star system among billions, orbiting the galactic center, just like the planets orbit the Sun. Within the vast expanse of the Milky Way galaxy, our solar system resides in a region known as the Orion Arm. This arm, named after the constellation Orion, is a minor spiral arm located between 2 larger arms, the Perseus Arm and the Sagittarius Arm. Think of the Milky Way as a city and the spiral arms as its neighborhoods. Our solar system is located in the Orion Arm neighborhood, a relatively quiet and sparsely populated area compared to the bustling city center. The Orion Arm is home to a variety of celestial objects, including star clusters, nebulae, and molecular clouds. Star clusters are groups of stars that form together from the same cloud of gas and dust. Nebulae are clouds of glowing gas and dust, often illuminated by the light of nearby stars. Molecular clouds are dense and cold regions of space where new stars are born. Our solar system is constantly moving through the Orion Arm, completing one orbit around the galactic center every 230 million years. As we journey through space, we encounter a constantly changing cosmic landscape. Section 5. Beyond the Milky Way, the local group of galaxies. Venturing beyond the Milky Way, we encounter a collection of galaxies known as the local group. This group, bound together by gravity, consists of over 50 galaxies, with the Milky Way and the Andromeda Galaxy being the 2 largest members. Imagine a small town with a few dozen houses scattered around. Each house represents a galaxy, and our town is the local group. The Milky Way and Andromeda are the 2 biggest houses on the block. The Andromeda Galaxy, our closest major galactic neighbour, is a spiral galaxy, similar in size and shape to the Milky Way. It lies about 2.5 million light-years away from us and is on a collision course with our galaxy. Don't worry though, the collision is not expected for another 4 billion years. The Triangulum Galaxy, the third largest member of the local group, is a spiral galaxy located about 3 million light-years away. It's significantly smaller than both the Milky Way and Andromeda, but still contains billions of stars. The local group is a dynamic environment where galaxies interact with each other through gravity. These interactions can lead to galactic mergers, where two galaxies collide and merge into a single, larger galaxy. Section 6. Galactic Clusters, the Virgo supercluster. Zooming out even further, we find that the local group is just one small part of a much larger structure called the Virgo supercluster. A supercluster is a vast collection of galaxy groups and clusters, all bound together by gravity. Think of the Virgo supercluster as a large metropolitan area, with the local group being just one neighborhood among many. This cosmic metropolis is home to hundreds of galaxy groups and clusters, each containing millions of galaxies. The Virgo supercluster is estimated to be about 110 million light-years across and contains tens of thousands of galaxies. It's one of millions of superclusters that make up the large-scale structure of the observable universe. At the heart of the Virgo supercluster lies the Virgo cluster, a massive cluster of galaxies located about 54 million light-years away. This cluster contains thousands of galaxies and is one of the most massive objects in our cosmic neighborhood. Section 7. The Observable Universe. A glimpse into the vast cosmos. The Virgo supercluster, while immense, is just a tiny fraction of the observable universe. The observable universe is the portion of the universe that we can currently observe from Earth. It's the sphere of space from which light has had enough time to reach us since the Big Bang. Imagine standing on a high mountain and looking out at the horizon. You can only see so far, limited by the curvature of the Earth. The observable universe is like that horizon, but on a cosmic scale. The observable universe is estimated to be about 93 billion light-years in diameter and contains trillions of galaxies. It's a truly mind-boggling concept, and it's important to remember that this is just the portion of the universe that we can currently see. The universe is constantly expanding, which means that the observable universe is also growing over time. As more time passes, light from more distant regions of the universe will have time to reach us, expanding our view of the cosmos. Section 8. The Expanding Universe. A universe in motion. One of the most fundamental concepts in cosmology is the expansion of the universe. This expansion, first observed by astronomer Edwin Hubble in the 1920s, means that the fabric of space itself is stretching, carrying galaxies away from each other like raisins in a rising loaf of bread. Imagine drawing dots on a balloon and then inflating it. As the balloon expands, the dots move farther apart, just like galaxies in the expanding universe. The expansion of the universe is not like an explosion, where galaxies are flying away from a central point. Instead, it's the space between galaxies that is expanding, carrying them along for the ride. The farther apart two galaxies are, the faster they appear to be moving away from each other. The expansion of the universe has profound implications for our understanding of the cosmos. It tells us that the universe was once much smaller and hotter than it is today, and it suggests that the universe may continue to expand forever. Section 9. Dark Matter and Dark Energy, the Unseen Forces. While we can observe a lot of matter and energy in the universe, there's a lot more that we can't see. These mysterious components, known as dark matter and dark energy, make up the vast majority of the universe's mass and energy. Imagine a play where you can only see the actors and the stage, but you can hear the audience and feel their presence. Dark matter and dark energy are like the audience. We can't see them directly, but we know they're there because of their effects. Dark matter is a type of matter that doesn't interact with light, making it invisible to telescopes. We know it exists because of its gravitational effects on visible matter, such as stars and galaxies. Dark matter acts like an invisible glue, holding galaxies together and influencing their motion. Dark energy is even more mysterious. It's a hypothetical form of energy that permeates all of space and is thought to be responsible for the accelerating expansion of the universe. We don't know what dark energy is, but its existence is inferred from the observed behavior of the universe. The study of dark matter and dark energy is at the forefront of modern cosmology. Understanding these elusive components is crucial to unlocking the secrets of the universe. Section 10. A cosmic perspective. Earth's place in the universe. Our journey through the cosmos has taken us from our home planet, Earth, to the edge of the observable universe. We've encountered planets, stars, galaxies, and cosmic structures of unimaginable size and complexity. What does it all mean? Imagine a grain of sand on a vast beach. That's what Earth is like in the grand scheme of the universe, a tiny speck of matter in an ocean of space and time. And yet, on that tiny speck, life has emerged and evolved, eventually giving rise to us. Our place in the universe is both humbling and awe-inspiring. We are a product of the cosmos, formed from the same stardust that makes up distant stars and galaxies. We are connected to everything in the universe, bound by the laws of physics and the fabric of space-time. As we continue to explore the universe, we gain a deeper appreciation for its vastness and complexity. We are but a small part of something much greater than ourselves, and yet we have the capacity to marvel at the cosmos and strive to understand our place within it.